Assalamualaikum and hi. So next we're going to look at the equation for kinetic energy. We know kinetic energy K is equals to half mv square. Ini adalah basic general equation kita where we have derived in this chapter where V is equals to plus minus omega A square minus X square. Kita neglect plus minus dekat sini just to substitute this V ke dalam sini. So your K now becomes 1 over 2M tempat velocity tadi tu masukkan omega A square minus X square whole thing square. So the reason kita neglect plus minus dekat sini tadi pun bila awak square kan dia hilang juga kan. So kita abaikan sahajalah. You just neglect the plus minus inside here. And then what's going to happen is half M. You square every term here becomes omega square. Third dengan square cancel become A square minus X square. So this is your equation for kinetic energy for simple harmonic motion. K sama dengan half M omega square bracket A square minus X square. Okay, I would like to just remind what is this M is. This is your mass of the object. Omega here is the angular frequency, A is the amplitude of the object, X is the displacement of the object. Next, we are going to look at the potential energy derivation. Potential energy general equation dia adalah U is equals to half kx square, where K here is the spring constant, X adalah displacement kita. K adalah spring constant, it depends on the type of the spring. Okay, so let us look at the oscillation of a spring in simple harmonic motion. Okay, summation F of a spring here is equals to the restoring force. Okay, restoring force of a spring Fs sama dengan mass time acceleration, because we know according to Newton law, summation F must equals to ma, whereas the force yang kita experience dalam spring adalah restoring force. Fs ini akan sama dengan ma. Okay, restoring force ini mempunyai equation dia sendiri iaitu negative kx. So now we are going to equate these two where negative kx is equals to ma because both of these equals to the restoring force. So rearranging this equation, kita akan dapat A is equals to negative kx divided by the mass. So this is your acceleration here according to this derivation. However, kita jumpa juga another equation for acceleration dalam simple harmonic motion adalah negative omega square x. So ini dua-dua adalah acceleration kamu. So we are going to now compare these two where your A is equals to negative kx square over m dan juga A juga sama dengan negative omega square x. So kita akan equate these two. The negative can cancel. Alright, so you will get your K here is equals to omega square m divided by x square x. Betul tak? Then you can cancel. Kita akan dapat kenapa ada x square? Sorry, my bad here. Sini tak ada x square. So the x here cancel each other. So you will end up with your spring constant is equals to omega square darab dengan m here. The spring constant is omega square darab dengan m. So you're going to substitute this equation for the spring constant yang kita cakap depends on the type of spring into the general equation of the potential energy. 1 over 2, tempat K kita substitute m, omega square x square. So ini adalah equation yang kita guna untuk simple harmonic motion for potential energy. Simple harmonic motion untuk potential energy. Alright. Okay, next, this is another subtopic dekat sini iaitu to emphasize the relationship between the total simple harmonic motion energy and the amplitude. When a body of mass m is in simple harmonic motion, its total mechanical energy iaitu E, total mechanical energy E adalah K plus dengan U. It is K plus with the U here. K dekat sini adalah kinetic energy, U dekat sini adalah potential energy. You're going to substitute K tadi kita belajar adalah half M omega square A square minus X square. And then campur dengan U pula half. Kita baru je derive M omega square X square. And then awak kembangkan this part of the equation. Awak kembangkan. And then awak simplify the equation, you will end up with your energy, total energy here is equals to half m omega square A square. Okay, m omega square A square, ataupun this m omega square adalah sebenarnya K kamu. It can also be written as E is equals to half spring constant darab dengan amplitude square. So your total energy, total mechanical energy adalah half mass angular velocity square amplitude square, ataupun half spring constant darab dengan amplitude square, because your K is equals to m omega square. So total mechanical energy of a simple harmonic oscillator directly proportional to the square of the amplitude. So kita boleh cakap the E here is directly proportional to the amplitude square. Okay, sebab half K ni kita assume dia sebagai constant. These all are constant. Okay, dia adalah nilai tetap dekat sini. Alright, that's it for the part of energy.